This lesson is on double number lines. This is simply a visual representation of our percent equation. The main idea that we need to remember in this is that 100% corresponds with our whole. So let's look at our example. A club is making friendship bracelets to raise money. Anna and Emily make 54 bracelets over the weekend. They need 300 bracelets total, and we are looking for what percent of the bracelets were they able to make. So we always start out by making our 100% number line, and this is going to represent our total of 300 bracelets. And this is our whole. Now, the number of bracelets that they made over the weekend is 54. And we can make an estimate here of this 54 and say we want what percent of the total is our 54 bracelets. So this is going to be our part. You don't have to be exact in placing your part on this second number line, but you can do your best. So we use our percent equation. Once again, we have our whole, which is our 100%, our 300 bracelets, our part, which is the 54 bracelets they made over the weekend, and our percent is what we're trying to find. So we use our percent equation. Part equals percent times whole. Part is 54 equals what percent, which is x, times our whole, which is 300. We use our properties of equality, our opposite operations, to solve for x. We divide both sides by 300, and we put it in the calculator and get x equals 0.18. Now, to answer the question, we want to know what percent. To turn that into a percent, we multiply by 100, and we get 18% of the bracelets were made over the weekend. Now let's look at an example. Bob's Tire Outlet sold a record number of tires last month. One of our salesmen sold 165 tires. We're told that this is 60% of the tires sold that month. We want to know what was the record number of tires sold. So we start out by drawing our 100%, and our title on this is going to be the total tires sold. This is our whole. Now we draw our second number line that represents how many are salesmen sold. We know that this is 60%, and we also know that this is 165 tires. So we can see here that our part is 60% of our total. We write our percent equation. Part equals percent times whole. Our part is 165 tires equals our percent. We know that that is 0.60 times our whole. How many tires did we sell whole? We don't know. In math, that's okay. So that's our x. To solve for x, we use our properties of equality, our opposite operations, and we divide by 0.60 on both sides, and then we get out our calculator, and we find out that x equals 275 tires sold in that month. Now let's look and see if that is a reasonable answer. We know that 165 is 60%, and so if our 100% is 275 tires, that looks like it would be a reasonable answer. So again, just a visual representation of our part, whole, and percent. Let's do our next example. What do we know? We know that Nick has 7,200 points in his fantasy baseball league, and that this is 20% more points than Adam. We want to know how many points does Adam have. So we're going to start out with our 100%, and we ask ourselves, what is our whole? What is everything being compared to? And what we find out is that we are comparing to Adam. Our indicator word here is than Adam. So this is Adam's points. And Adam's points is our whole. Now let's look at Nick. What do we know about Nick's points? We know that Nick has 7,200 points, and that is 20% more than Adam. So this time our number line is going to be longer than our 100%, and this is going to be 120%, 20% more than Adam. And we are going to label this as Nick's points. Nick's points is our part. And we know that Nick has 7,200 points. And what are we trying to find out? We are trying to find out how many points Adam has. So we use our percent equation. Part equals percent times whole. Our part is Nick. 7,200 equals our percent. This time is 120%. We take 120 and divide it by 100. Percent's always out of 100. It's 1.20 as our decimal. And our whole is the thing we're trying to find out. That's our x. So to solve for x, we divide both sides by 1.20, and we find out that x equals 6,000 points. And that's how many points Adam has. So let's take a look at our visual representation here. Is 6,000 a reasonable number? Yes, because 6,000 is less than 7,200, and we know that Adam's number line is smaller than Nick's, but it's not a lot smaller. It's only 20% smaller. So from 6,000 to 7,200 is a good value. So that's reasonable. Let's look at our final example here. Kurt has driven 276 miles of his road trip. He has 70% of the trip left to go. We want to know how many more miles does he have to drive. Where do we start? That's right, we do our 100%. And again, that's our whole. What does our whole represent here? Our whole is going to be the total miles that he has to drive. This is our whole because it's our 100%. Now this one's a little bit tricky. What do the words tell us? It says there's 70% of the trip left to go. So how far has he driven? You got it. He has gone 30% of the trip. And so this label is miles already driven. And this is our part. Now let's label what we know. We know that our part here is 276 miles. Now let's take a look at this. Are total miles going to be a lot more or a little more? Well, if we've only gone 30%, then our answer is probably going to be a lot more. So let's find out how many total miles there are on this trip. Part equals percent times whole. Our part is 276 miles that he already drove. We know that that is 30%, 0.30, times our whole, which is x that we don't know. We divide both sides by 0.30, and we get x equals 920 miles total. So now we have our mathematical value, but have we answered our question? We have not. Our question is, how many more miles does he have to drive? So we are actually looking for this part right here. Kurt has already driven this far, vroom vroom, but he still has this much left to go. So how are we going to find that? We subtract. We know that our total here is 920 miles, and if we take our 920 miles and subtract what we have already done, then that is going to give us 644 miles left to drive. So now we have answered our question. This one was a little bit tricky, but I believe you can figure these out. So once again, double number lines are just a way to visually represent our part, percent, and whole. Don't forget, the whole is always your 100%. Be careful to determine what represents the 100%. And then sometimes your part can be less, so less than 100%, and sometimes it can be more, like our problem we did that was 120%. I hope you enjoy using double number lines to solve percent problems.